All right. So this is class 7. This will be, we have 2 more classes left after this one. So the agenda, just gonna homework questions if anyone has any questions about the homework, functions composition, one-to-one functions, and then gonna talk about inverse functions. If you have any questions, just put them into the chat box. All right. So first, going to talk about functions. These are the basic function operations that we have right here. As you can see, first we have the sum for the addition or sum rule, you could say. So f plus function g is equal to f plus g. I'll show you, I'll give examples of those after, but these are just the rules. I would highly recommend that you write it down. The difference, function x minus function g of x is equal to function f minus g of x. The product rule, f times function f of x times function g of x is equal to function f times g of x. And then lastly, the quotient rule, f of g of x is equal to function f of x divided by function g of x, granted that function g of x does not equal 0, because if it were to equal 0, then the function, it would not be a function, it wouldn't be a true solution because you cannot have 0 as the denominator. All right, so I will show you guys these 3. So we have let f of x equal 4x plus 3 and let g of x equals x squared. Find function f plus function g of x. So since we know what these 2 functions equal, right? We can rewrite. So we know that just means that function f plus g of x. So first we know that function f plus g of x is equal to a function f of x plus function g of x. Next, we can plug the values in. So f of x is equal to 4x plus 3, and g of x is equal to x squared. And then very nice, and then boom, we have our answer. The answer to function f plus g is equal to x squared plus 4x plus 3. This pretty straightforward. Next one, we have f times g of x. What you would do here, again, plugging in the 2 values, 4x plus 3 times x squared. And then through that, you would get 4x. Okay. You would get 4x to the third. You would get 4x to the third plus 3x squared. All right, next one, we have f minus g of x. This one is very important because you have to, the order is really important, whether it's function f minus function g, or if it's function g minus function f, because then the negative symbol does matter. So you have 4x plus 3 in parentheses minus x squared this way. And then when you combine them, simplify, you get negative x squared plus 4x plus 3. Very important, because if you were to do x squared minus 4x plus 3, which would mean that you were doing function g minus function f, you would get, your answer would be x squared minus 4x minus 3, which would not be the answer. Lastly, function f divided by function g. Again, you simplify that, or you can break it down into f of x divided by g of x. And then you can plug in the values. You get, what f of x equals, that you plug it into there. What g of x equals, plug it in. So then you would get a 4x plus 3 divided by x squared. And then don't forget, I'm not sure how to type the not equal sign, but x doesn't equal 0. This is the important part to remember. Whenever you answer a fraction, whenever your answer is a fraction and the fraction has a variable in it, like x or z or something like that, always make sure to put in whatever the variable is and the not equal sign to whatever. Make sure the denominator does not equal 0. All right. All right, now let's take a few minutes. Let's take 5 minutes for you guys to work through these 4 questions. If you have any questions on how to do them, if you're a bit confused, just put your questions into the chat box and I'd be happy to answer them. All right, just take another minute or two to wrap up these 4 questions, and then after you're done, put your answers in the chat box. I'll take a look at them, and then I'll answer any questions you may have. All right, whatever you have done, just put them into the chat box, and I'll take a look at it. Alrighty, I'll just quickly go over them. I know it's the same questions as the previous slide, but I'll just quickly go over them again, how you do it. Again, you just take apart these functions. F, you split it apart into, function x. First one, you split it up into f of x plus g of x. And then again, you substitute what f of x and what g of x equals into the equation, and then you get your answer. Again, that's x squared plus 4x plus 3. Next one, again, you just split it up into f of x minus g of x. G of x. And then again, plugging it in, you would get 4x plus 3 minus x squared. And then same for those 2 problems. Again, x multiplied by g of x. So the main thing to know about and to remember about these kind of problems is just that when you see them, remember the rules that I talked about, the sum, difference, product, and quotient rules. Just remember these and you'll be good to go. Remember, just take basically just the 3 steps, just to take apart the function, split it up into, f and g or whatever those 2 functions may be, and then substitute in the values of what they equal, and then you combine them together and solve. Right. Does anyone have any questions about how to solve these problems, or just about functions in general? All right, I do not see any questions, so I will keep going. Next, we're going to talk about function composition. So what is function composition? A function composition uses the output from the first function as the input to the second function. So for example, the function composition of functions f and g is f of g of x, or it can also be written as g of x of f. Those are just the different ways to write it. All right. I'll do an example. I think it looks a bit confusing at first, but once we take a look at an example, it'll be a lot easier. This is a meme I found. It somewhat explains what function composition is. So if you have f of x, which is chocolate chip cookies, and you have g of x, which is the ice cream. So f of g of x would equal the ice cream and ice cream cookie, whereas g of f of x would equal chocolate chip cookie dough. So the order really matters, whether it's f of g of x or if it's g of f of x. So the order really matters in this case. So we have, I'll do the first example. So we have, and then, to express f of g of x, you would use this little O symbol, and then a lot of people just call it fog. But the correct term is usually just f of g of 2. So we have these two values. We're given the two values. If f of x is equal to 2x minus 5, and g of x is equal to x squared plus 1, find f of g of x. So what we know from this, that f of g of x also means a function, f means this, right? G of x outside, and then f of g of x. So what does that imply? So first, we would, of course, solve what g of x is equal to. And here we're given that x equals 2. So first thing we would do, we would plug in x for 2 into the function g of x, which is given up here. So again, g of x is equal to x squared plus 1. So in this case, g of 2 would equal 4 plus 1, which is 5. 4 plus 1 equals 5. All right, so now we have the first part complete, right? We found out what g of x equals. So now we can simplify this equation. How do we do that? We simply turn it into f of 5. Why? Because in this first equation, it's as you can see, it's f of g of x, and now we have determined the value of g of x, which is 5. G of 2 in the value here. So G2 is equal to 5. That way we can plug it in, and it's just the function f5. Then we take a look at what does f of x equal? F of x equals 2x minus 5. That way we plug it in, f of x is equal to 2x minus 5. Then we would plug it in. So f of 5 is equal to 10 minus 5, which equals 5. So your final answer to this would be 5. And then I'll do g of f as well, so you guys can see the difference between the two. So first, instead of f of g, you would get g of f, which entails this kind of equation, the two differences. So first, in this case, instead of finding g of 2 first, you would find f of 2. And then what does f of 2? So you would use the same equation, and using the same equation, f of x equals 2x minus 5, plug in the 2, f of 2 is equal to 4 minus 5, which equals -1. Then what do we get? We get g of -1, because, again, it's just a matter of substituting f of 2, because in this case, it would be f of 2, g of f of 2. So what does so we already found out what f of 2 equals. F of 2 equals -1. So then we plug it in to this position right here. Then what do we get? We get g of -1 is equal to x squared, g of x, g of -1, using the same equation that they gave up there. So x squared plus 1, which is just 1 plus 1, which equals 2. So your final answer for this, for the second problem, would be 2. So you can see, even though it's just a simple matter of switching the letters, f of g or g of f, it can have the two answers are completely different. You have 5 and you have 2. So let's take 4 minutes or so to work on these two problems. The next two problems, you have if f of x is equal to root x, and then g of x is equal to x plus 1, find f of g equals f of g of x. Although it doesn't give you the number, it's the same principle of plugging x into the function and then solving that way. All right, let's take another minute or so to wrap up the two questions, and then after in a minute or two, just put your answers into the chat box. It's fine if you didn't get to both of them. If you just got to one, that's fine. You can just put the answer to the first one or the second one, or whichever one you did finish into the chat box. All right, just put whatever your answers you got into the chat box, and I'll take a look at them. All right. So, yep, as many of you wrote, for the first one, the answer would be the square root of x plus 1. Again, how we solve that, write it in the form f of g of x, right? And then first you solve for g of x. This time it's pretty simple. You don't have to plug anything in. You just have the standard g of x. Since it's just x, you don't have to plug anything in. So g of x just equals x plus 1. And then afterwards, you put that into function f of x. So function f of x plus 1. So this, keep in mind, very important, this important part, the x plus 1, even though there's an x there, that doesn't signify that x is the only thing being square rooted. That means the whole thing is x in this term, in this equation. So your final answer would be f of x. So f of g of x equals square root of x plus 1 in parentheses. All right. For next one, we have g of f. So for that one, it is similar. You would get g of f of x. Right? Plug in what f of x equals. F of x equals square root of x. And then you plug in g square root of x. G of x, in that equation, g of x equals x plus 1. So plug in root x for x, and you would get that your answer would be square root of x plus 1. Make sure to note the discrepancy between these two. For the first problem, the square root is encompassing the whole equation, the whole x plus 1, whereas for the second one, the square root is only covering, it is just square root x. This 1 is just still 1, it's not square rooted or anything. So just a minor discrepancy to keep in mind. All right. Does anyone have any questions about how I got these answers, or how, if you're confused on any part of this? All right, I do not see any questions. All right, continuing on. So now we're going to be talking about one-to-one functions. So what are one-to-one functions? For one-to-one functions, each x value corresponds to only one y value, and each y value corresponds to only one x value. A one-to-one function must pass the horizontal line test. So I think most of you have probably already learned this, but when you're determining if something is a function or not, it has to satisfy the vertical line test on the graph, on the XY plane, right? You put a vertical line through any part of the graph, and it cannot overlap. It cannot overlap in more than one place. So, for example, if we had a function like this, right? Draw this, the XY plane, X, Y. So in this case, right, this would be a function. This would pass the vertical line test. This isn't a straight line, but wherever you draw a line, wherever you draw a straight line, the function, it only touches the function at one point. However, for it to be a one-to-one function, it has to pass the horizontal line test, meaning that whenever we draw a horizontal line, it cannot touch the function in more than one place. So in this case, it would not pass the horizontal line test. So it would be a function, yes, but it wouldn't be a one-to-one function. So on like any tests or homework you might come across in the future, make sure to keep that in mind. So for something like this, yes, it would be a function, but no, it would not be a one-to-one function. And always keep in mind that it has to satisfy the vertical line test and the horizontal line test. So for example, let me draw another one. So for example, if you have a function like this, right? Yes, it does pass the horizontal line test, wherever you draw a line. Ignore that. It never crosses, it only touches at one point. But however, if you draw, it does not pass the vertical line test. So therefore, it is not a function, meaning that it cannot be a one-to-one function. Does that make sense? Just give me a thumbs up. All right. All right, so now so these are two examples of functions. So we have function R, and here are some of the points that function R goes through. So we have 1, 2, 3, 4, 5, 6, 6, 7. And so here we would have to determine if it is a one-to-one function, and the answer is yes, it is a one-to-one function. Why? Because for each, as they said, each x value can only correspond to one y value, and each y value can correspond to only one x value, meaning that you cannot have any duplicates of x's or y's, basically. And in this, we see that, yes, indeed, there are no duplicates. There are 2 6s, but they are in different positions. One's in the y, and then one's in the x. So yes, it is a one-to-one function. There is no overlap. For this one, however, it is not it does not pass the vertical line test. It's not a one-to-one function. Why? Because we have 7 and 7 in the y value. So that way it does not satisfy the condition that each x value can only correspond to one y value, and each y value can only correspond to one x value. So this does not fit. As you can see, this y value, the same y value corresponded to 2 x values, not 1. So that way, in this case, no, it is not a one-to-one function. All right. Next, we're going to talk about inverse functions. That's what it looks like at the top. It's basically exponent -1, but you would never read it as f of negative -1 or f negative exponent 1. You would just read it as f inverse. So for every one-to-one function, you can always find an inverse function by switching the coordinates of the original ordered pair. For every one-to-one function f with ordered pairs x, y, the inverse function f inverse has the ordered pair y, x. So basically, in short, the domain of f, which is the x values, becomes the range of inverse f, the y values, and the range of f becomes a domain of inverse f. So basically what this is saying, it's a very complicated way to say for, a function f, right? You have this point 2, 3. But for the inverse function, inverse f, they would have the ordered pair 3, 2. You would just flip-flop the x and the y in the original one-to-one function, and boom, there you have it. You have a point that is in the inverse function. All right. So I'll do the first 2 points, and then you guys can do the last 2. So find the inverse of the function g. So for the first point we see, we have 3, 4, right? And then knowing taking what we learned about the inverse functions, inverse g. So one of the points you would get 4, 3, and 2, 6, right? For these 2 points. Again, when you have an inverse function, you swap the x and the y. The 4 in the y spot becomes the x. The 3 in the x position becomes the y. And the same goes for 6, 2. Since this one is quick, just we'll take like 30 seconds real quick. Tell me what the coordinates would be for the last two coordinates in the inverse function, these two. Type them in the chat box. All right, nice job. Yes, for the first one, it would be -3, 2. And for the second one, it would be -5, 4. All right, here we go. Next, how to find the equation of an inverse function. Just remember, when you're doing it, remember these 4 steps. So first, replace f of x with y. 2, interchange x and y. 3, solve the equation for y. And then 4, replace y with the notation f inverse f of x. All right. And here we have it in play. So this is an example. So find the inverse of f of x equals 6x minus 1. So first step, replace f of x with y. So y equals 6x minus 1. Swap x and y around. So you would get x equals 6y minus 1. And then you would solve for y. So you would get y equals x plus 1 divided by 6. And lastly, you would just, once you have y separated on one side of the equation and without any number in front of it, just plain y, you would substitute y in for f exponent -1 of x. And there you have the inverse of the function. Pretty neat little way to find out the inverse. All right. Next up, we have how to determine if two functions are inverses of one another. This is going back to what I talked about in f of x, the little o symbol. So if function f is a one-to-one function, then the inverse of f is inverse f, such that f of inverse f, of x and equals x, and f of inverse x f of x is equal to x. Sorry, a lot of inverses and a lot of functions, making my tongue twister right there. All right. So here is an example. So you have these two functions, right? And then you have to prove that f of x is equal to 4x. So to prove these two are inverses, so what do? You fog it, or you f of g of x it. Because as we talked about in the first part, if they are inverses, when you put them into this function, the answer will always equal x, right? Okay, so first we fog it. So f of g x should equal x. What does this equal? F of g of x right? So then we have function. So first, what does g of x equal? G of x equals x plus 1 divided by 4. So we just plug that in and then we get f of x plus 1, 4. And then finally, you would get you would plug in x plus 1 divided by 4 into the function f of x. So f of x plus 1 divided by 4 equals 4 times this is a bit hard to write. X plus 1 divided by 4 minus 1, right? And then in the end, once you simplify it all out, you get x plus 1 minus 1, and the answer you are finally left with is x. And then in this case, it would prove that the functions are indeed inverses of each other, because when you solve it all out, the answer is x. Again, since sometimes they might give you a number to plug in for x, but since this time it's just f of x, it didn't state a number. It makes it a lot simpler. You don't have to change anything in the equation, because when you plug in x for x, it's just x. So g of x is equal to this. You plug in it, you plug it back in the function for g of x, and then you plug this whole equation into the x slot for f of x, and then you plug that in as you would with function, and then you would solve. Does anyone have any questions on proving function inverses? All right, I do not see any questions. All right, so here are some practice problems for you guys to work on. So these three determine if the functions are 1-to-1 functions. Let's take 3 minutes to go to work on these. Remember, functions are 1-to-1 functions if there's only one, if every x value corresponds to only one y value, and if every y value only corresponds to one x value. All right, let's take 3 minutes, and then just put your answers in the chat box. All right, I think most people have answered, so I'll just go over them now. It would be, first one would be yes, second one would be no, and third one would be yes. The second one would be no, because, let me, you have two y values. You have two of the same y values, so that would make it not a 1-to-1 function. Okay. Next up, some more practice problems. So find the inverse. We'll take about, let's take about 6 minutes to work through these. So first, find the inverse of the 1-to-1 function. Again, when you find the inverse, you just flip the x and the y values for each of the coordinates. And then find the inverse of f of x equals 5x plus 2. If any of you guys forgot how to find the inverse, just message me in chat, and I'd be happy to go over the steps again. And then lastly, if f of x equals 3x plus 2, prove that prove that the inverse of f of x equals x minus 2 over 3. All right. Once you're done, just put your answers into the chat box. All right, we'll take about 2 more minutes, just wrap up the questions, and then I'll put them in the chat box and I'll go over them. All right. So for the first one, find the inverse, the inverse would equal 4, 3, 0, 0, 0, 0, -2, 8, 2, and then 6, 6. For number 2, for the inverse, you would get f inverse -1 x. The f inverse of x is equal to x minus 2 divided by 5. And lastly, to prove it, you can fog it, or f of -1 of x, or you can do it the other way, f of -1, f inverse of f. You can prove it either way. Again, you would just, in this case, I'll just do one of them as an example. You would plug in this entire equation for x in this case. So you would take this entire equation and plug it into x. And then in that case, 3x plus 2, 3 times x minus 2 divided by 3 plus 2. In that case, you would get the 3's would cancel out, and then you're left with x, and then the -2 and the +2 cancel out, and all you're left with is just x. And then as we talked about, whenever you have to prove an inverse, after you fog it, or f of inverse f it, the answer should be x for you to prove that the functions are inverses. So great job, everyone, on completing those.